Hello everyone, back tuning into the third Winter 2018-19 update from GWV.com. So we've done 2 updates so far. We are 2 down and we've got several more still to go. In fact, there's going to be 13 seasonal updates of Winter of 2018-19, 13 updates to come, as well as 3 seasonal model roundups, which will be released on the final Saturdays of the next 3 months, September, October, November. So a lot of updates still to get through. We're still very early on in the season of Winter 2018-19 updates. And this is going to be a follow-on, really, from last week. We're going to have a look at the driest summers on record for England and Wales and the winters that followed them. Last week, of course, we looked at the hottest summers on record for England and Wales and the winters that followed them. And we're going to bring it all together and show you what hot and dry summers can mean for the winter, for the winters that follow them. So that will cover the final batch of analogues for the summer event. Next week we'll be off into something else. But before we get to the analogues, we've got loads of other things to talk about. So it could be an extended video. Can't watch it all in one go. Don't worry, it will be kept at the website indefinitely, because later on today it'll be placed on the winter updates and forecast page. There'll be an extensive written summary that goes with it as well, just going over everything that we discuss in the video. Big thank you to our friend James Acrill for supplying us with the analogues. Our analogues guru has again come through for us. Even in the final hour before recording this video, I was being a bit of a nuisance to poor James and getting him to create some last minute analogues for us. So as always, a big thank you to James for giving us the analogues, sorting out the analogues for us. I haven't got time to do it myself, so I won't be able to do the analogues for these season model roundups without our analogues guru James. So big thank you to James for that. I think that pretty much covers everything that we've got to mention for the video. So without further ado, I think we better get on with it. And let's begin the third Winter 2018-19 update. We're going to begin this week by having a look at Arctic sea ice and Siberian snow cover. So we're going to start with the CH Arctic Interactive Sea Ice Graph from National Snow and Ice Data Centre. So if I scroll you down, you'll be able to see that the grey line here is the trend line for the time of year. Obviously, we are in the melt season for Arctic sea ice, so the grey line tells us that we should be losing ice at this time of the year, but the orange line here is 2018's melt season. So you can see I've had another big melt season. We're almost at the end of it now. I think we'll probably discard this next week. Probably have one last look next week. Then after that, I don't think there'll be much point in looking at this further on. So we're nearly done with this. But we can see that we have had another big melt season again this year. We're well under the grey line. This orange line for 2018 is well under the grey line, so again has been a very big melt season to say the least. We're going to go right way back to 1979 with this chart. So if I can try and flip this over so it doesn't look like there we go, we've gone over to 1979 there. So let's just show you 1979. So actually that's how it looks in terms of the melt season for 1979, above the grey line, above the long-term trend, obviously retaining a lot of ice in 1979. You can see the difference between 1979 up here and 2018 down there. I won't run you through all of the years. Let's get rid of 1979. And then we'll see if we can get ourselves back to the current year. So it's a little bit slow to run this. So what I'm probably going to have to do is refresh the page, because we're not getting back to the more recent years. So let's just give that a bit of a page refresh, and hopefully that will resolve the issue. Sorry about this, everyone. It seemed like a good idea to show you 1979 at the time, but it perhaps wasn't such a good idea after all. And the website has decided to run very, very slowly as well in terms of loading this up. So there we go, we're getting the website up now. Right, so we are back to our more recent years. Don't know what went wrong there. So we're back to the trend, which is the grey line. We're back to the orange line, which of course is this year, 2018. And this green dash line is the death spiral of 2012. Let's get rid of that to start off with. We'll begin at 2005. So we're going to fill in every year to 2005. That's how the Arctic melt season looked in 2005. Above this year quite firmly. That's 2006, again significantly above this year quite significantly. That's 2007, and we have been very close to 2007's melt season, although now we are a little bit above it. The blue line there indicating 2007's melt season, the orange line indicating the current melt season. So we're a little bit above 2007. That's 2008 with virtually bang on 2008's melt season. It's 2009, we're a little bit underneath 2009, and that's 2010. Very close to 2010's melt season. That's 2011. I think we're a little bit above 2011. 2011 ran very close to 2007, really. Again, that's 2012, the green dash line. That's the death spiral when we lost a catastrophic amount of Arctic sea ice. It was termed the death spiral because it really was very, very grim in the Arctic in 2012 for Arctic sea ice loss. That's 2013, and that was a rebound. So after the death spiral, things swung back quite well in 2013 in terms of the amount of ice that we retained. And 2014 was very similar too. It's starting to become a little bit more difficult to make out each individual line, of course, now. That's 2015. We're very close to 2015 for this year. It's hard to make that out, but it's a yellow coloured line. You see it there a little bit, and you can see it around here as well. So very close to 2015 for this year. That's 2016. That was quite close to 2007, so a little bit above 2016. And then that is the most recent year, 2017. It's very difficult to make that out. So let's start getting rid of some of these now. We're going to get rid of all of these years except for the current year and except for 2012 and 2017. So there we go. You can see that actually the blue coloured line is the amount of ice that we lost in 2017. The orange coloured line is the amount of ice that we've lost this year, and they're virtually bang on with one another. So it's been another very big melt season indeed. Not as big though, not as catastrophic, nowhere near actually as 2012. 2012 is down here, but for 2017, 2018 we're around there. We are very much undertrained. So obviously another really big melt season, and we've had most years, with the exception probably of 2013 and 14, most years have been around this area since 2007. What happened in 2007 looks as though it was very much a defining moment, if you like, and most years have been coming in around 2007 in terms of the Arctic melt season, with the exception of 2012, which was a lot worse than 2007. Unfortunately, we haven't had another death spiral year like 2012. And then, of course, we had a couple of rebound years in 2013 and 2014. It's been another big melt season. It is another big Arctic melt season. And so the connection with this is that it increases the blocking signal, we think, over the North Pole. There's a lot of doubt and uncertainty about what the effects of losing all of this ice in the Arctic can be. But increasingly, the idea is that the more ice we lose over North Pole, the greater the risk in the winter of getting northern blocking. So another big Arctic melt season probably favours northern blocking for this winter. But of course, it's not as straightforward as that. Now, this is how things were looking across Siberia in terms of Siberian snow cover, and we also see Arctic sea ice with this as well. So let's deal with Arctic sea ice first of all. This is from last week from the National Ice Centre, and we can see that up here in the northern latitudes over North Pole, the yellow colours are where we've got Arctic sea ice. The blue colours there, such as we see there, and again, such as we see there, is where all of that ice has melted. So you can see we have had another big melt season quite clearly. This is the amount of snow that we had across Siberia, eastern Siberia last week. So we have got some white patches showing up there. Not many of them, but there were a few white patches appearing across eastern parts of Siberia last week on the 7th of September. Let's have a look at the very latest, which takes us through to the 14th of September. And we can see that, again, we have lost a little bit more ice up over the North Pole, so that's to be expected. We haven't quite bottomed out in terms of the melt season yet, so you'd expect a little bit more ice to go. We will virtually be turning the corner on that, and the refreeze will begin in about another week, I would have thought. So across Siberia, though, they've actually increased back to snow cover a little bit again. So this situation last week, in terms of Siberian snow cover, this situation now, I mean, this is all very minimal sort of stuff. We haven't got much snow cover at all across Siberia. It doesn't really matter to anything at the moment. This becomes much more important in October, when we will see all of this area, or most of this area, filling up with snow through the course of October. And how quickly that happens can determine how strong the Siberian high is going to be. So we'll discuss this a lot more when we get through to October. But we're certainly off to a reasonable start. I was going through the list. I won't show you the list of years. We can go all the way back to 1997. And there are very few years, actually, that have this much snow cover at this point in September. I mean, it is very early days. This is only the 14th of September when this chart is from. So it's really early days to be getting any sort of snow cover across Siberia. In fact, several of the years I looked at between 2018 and between 1997, several of the years don't have any snow cover whatsoever at this point across Siberia. So it's very, very early days, and we're off to a decent start, let's put it that way, in terms of the Siberian snow cover season. Incidentally, this is how things were looking last year, so you can see that for Arctic sea ice, again, just confirming what I've already looked at, very similar in terms of how much ice we've lost this year compared to last year. Again, this is from 14th of September 2017. But in terms of Siberian snow cover, again, more snow cover this year, albeit it is still small amounts, but there's definitely more snow there this year than there was at this point last year. Remember, this becomes much more important when we get through to October. More on that in the coming updates. Right, solar activity next. So this is a solar disc on our side of this today from solarham.net, and we've got a spotless solar disc. So that means sunspot numbers are, well, there aren't any sunspots at all, and solar activity is at very low levels, and Solarham is forecasting solar activity to remain at very low levels over the next 3 days. This is the GWV's third winter update solar activity tracker sent through by our good friend James. James Aquila sent this one through, updated to today when I'm recording the video, 15th of September. So you can see we have been having some very small sunspots. I'll talk you through each line. The orange line is each individual day's sunspot numbers, and then the thick green and the thick red lines are our trend lines for the season. Don't talk about this very much up here, but we will actually be doing a winter update. I think it's going to be the 5th winter update on 30th of September. We'll be doing the 5th winter update then, and that's going to be a little bit of a solar activity special, a little bit of a solar cycle special for the 5th winter update on the 30th of September. So I'll probably talk you through that line, or those lines up here, a little bit more then. But let's concentrate on these lines down at the bottom. So we've got the orange line, which is each individual day's sunspots. We had a very long run starting through most of the summer, actually going on for most of the summer, starting in the middle of June and going on through to the middle of August, where we barely had any sunspots whatsoever. And so that meant that our trend lines, the thick green and the thick red lines, actually went virtually to the floor. Since around middle of August, we have had a little bit of a tick up in sunspot numbers. So you can see some of the days have had some sunspots, but of course other days have had no sunspots at all. From last week, we have had a few days with a low level of sunspot numbers, but also some days, today's very much indicative of that, where we haven't had any sunspots at all. And so after a very slight tick up with our trend lines from this really low level that was in around here back in the summer, we do actually see that the trend lines, particularly this red line, are beginning to edge downwards ever so slightly. Overall, solar activity is at very low levels. We have entered into solar minimum. When true solar minimum is, and when we move into solar cycle 25, is an interesting question, and you never really know when you've entered the next solar cycle until you've done it. So I would anticipate around 6, maybe 12 months' time, we will begin solar cycle 25. But it is possible that actually solar cycle 25 doesn't begin until 2020, and so that will make things a little bit complicated in terms of our winter forecast. Is this going to be the true solar minimum winter, or will it be next winter, 1920, that is the true solar minimum winter? That makes a little bit of uncertainty within the analogues in particular, and there'll be a lot more about this when we do that solar special for the 5th winter update that's coming up on the 30th of September. But what we can say is that whether this is the true solar minimum winter or not for 2018-19, solar activity will be at a very, very low level indeed for this winter. We'll be keeping an eye on the solar tracker over the next few weeks and months. Big thanks to James for sending that through. Right, so this is a new feature that we are adding into winter updates for this year. This is from weatheriscool.com, and it's a forecast for the strength of the zonal flow at 10 HPA, which is in the stratosphere. So it's a strength of the sort of zonal flow within the upper boundary of the atmosphere over the North Pole at 60 degrees north. So what you need to know with this is that the black line is the trend line in terms of the strength of the zonal flow at 10 HPA at this time of year. And obviously we're entering into the autumn and winter, so the zonal flow is expected to be strengthening. The westerlies will be increasing and getting stronger and stronger. Now, this is a forecast chart, so the first thing you need to know with that is that this green area just here is the GFS model and its ensembles. So that only gets us a couple of weeks in, though. It just gets us to the start of October now in terms of the GFS and its ensemble. It goes through just over 2 weeks out. You can see that the forecast from the GFS is to keep the zonal flow at 10 HPA, to keep the stratospheric strength of the stratosphere at a weakened state, really. It's underneath this black line, that green area, so it's underneath trend as we go through to the end of the month and the beginning of October. But of course that only gets us a couple of weeks in, and these coloured lines then are from the CFS V2, the long-range model, and that gets us much further into winter. So we've got the month of October just here, we've got the month of November just here, and then we've got the month of December just there. So we can actually go up to New Year's Eve, 31st of December, with this forecast from the CFS and the CFS ensembles. You can see that through most of October, the CFS output is still signalling the strength of the stratospheric flow at 10 HPA, the zonal winds, to be in a rather weakened state, generally close to or a little bit under the average, which of course is strengthening at this time of year. But that becomes more obvious, I think, as we get through into November. This is the month of November just here, and you can see that many of these coloured lines, these pink and blue lines, are quite substantially weakened during November. This has been a consistent signal since we've been looking at these. We're up to update number 3 now. Each update so far has shown weakened zonal winds at 10 HPA. in the stratosphere during the course of November. So you'd expect the West to be in a rather weakened state this November, and that might allow for some colder conditions through the early winter. And as we get through to December, just here, you can see that again, these coloured lines are generally a little bit under trend. There is a bit of a recovery from this pink line. This is one of the CFS runs that's getting back close to average during the course of December. But many of these pink lines and that blue line as well are under trend. Actually, we do have this one that is really crashing. Actually, I'm not sure what's going on with that one, but that CFS member is at a very low level. The upshot is that I think November and December are still being forecast by the CFS model to have weakened zonal winds in the stratosphere at 10 HPA. So this could allow for some colder conditions through the early winter. You have to say where we're starting off from in terms of the GFS and its ensemble forecast with a weakened zonal flow at 10 HPA. It is starting off at quite a weak basis already through September. And it looks like after a little bit of lift up during October, November and December could see those zonal winds easing off. If that happens, it might allow for some early winter blocking. We'll keep an eye on that. Let's have a look at the oceans then. So we're going to deal with the Pacific first of all, then we'll have a look at the Atlantic after that. I forgot, by the way, to have a look at the Atlantic in last week's second update. So sorry about that. I will make up for it in today's video. So we're going to begin with the Pacific Ocean. This is how the sea surface temperature anomalies were looking in the Pacific last week. We did last week's second update. We've got the Northern Pacific up here, and then we've got the ENSO region just there. Of course, we've got the North Atlantic over here. We'll talk about more about that in a few minutes. That's how things were looking last week. This is the latest from now. This is from the 13th of September. And you can see that, let's again look at the ENSO region first of all. So, very little change in the ENSO region. It has possibly warmed up a little bit, though, over the past week. These orange blotches here over in the eastern part of the equatorial Pacific, they're getting a little bit more intense. And here in the central and western equatorial Pacific, possibly warming up a little bit more there. Maybe losing a little bit of those, a few of those blue patches as well. What do you think? That's last week and that's this week. I think a little bit of warming has taken place through the equatorial Pacific over the past week. It's still not El Nino. That is still not really an El Nino signature. But yes, I think over the past week a little bit of warming has taken place through the equatorial Pacific. In the Northern Pacific, very little change. It remains really quite warm in the Northern Pacific Ocean. I want to show you the latest forecast from 3 models for the ENSO region. So this is the CFS V2, still going for a weak to borderline moderate El Nino event. It has backed off it ever so slightly compared to a couple of weeks ago when it's going up to around 1.5 degrees above average. This line just here, you can see from the black dash line, that has been pulled down a little bit, but perhaps not quite as much as I was expecting. And it does look as though CFS is still going for a weak to borderline El Nino. To get an El Nino, these are our dates are along the bottom and temperature anomalies are along the side. To get an El Nino, we've got to go above 0.5 degree above average. We are doing that quite well. So around 1 degree above average is going to be a weak El Nino. 1.5 degrees above average will be moderate. 2 degrees above average will be strong. And above that, you're into Super Nino territory. So the black dash line there, somewhere between 1 and 1.5 degrees. So it's on a borderline really between weak and moderate El Nino from the CFS V2. A little bit surprised it hasn't backed up a signal more. What about the ECMWF? This is the latest ensemble plume from the ECMWF for the region 3.4 area of the equatorial Pacific. Again, very similar to what CFS is showing, actually. We've got our dates that are on the bottom. temperature anomalies are on the side. So that's 1 degree above average just there. So to get an El Nino designated, you've got to be around 1.5 degrees above average, somewhere around there. The warmest ensemble members in terms of that central part of the equatorial Pacific are going up to kind of like 1.5 degrees above average. The coolest ensemble members are keeping things bang on ENSO neutral. So if you assume that somewhere in the middle of that is broadly where the ensemble plume is, then again it's kind of like it's a little bit lower than the CFS-V2, I have to say. CFS-V2 ensemble mean, remember, between 1 and 1.5 degrees above average. The ECM ensemble plume is kind of like a little bit under 1 degree to 1.5 degrees above average, or let's say perhaps 1 degree just there to around sort of underneath 1.5 degrees above average down there. I think that's broadly where the ensemble plume is. So that's kind of like on a knife edge between ENSO neutral, on the warm side of ENSO neutral, and weak El Nino. So it is lower in terms of the El Nino forecast. It's cooler compared to CFS-V2, but still just about getting to an El Nino event. And then this is the Jamstec model, and again actually this is quite similar to CFS-V2. So our dates are along the bottom, temperature anomalies are on the side, starting off around there just on the periphery of ENSO neutral to borderline El Nino. By the time you get through to the start of next year, and it is very late lifting this up, this line it's very late lifting it up, but by the time you get through to January, that's January just there, we're kind of like peaking this event at somewhere between 1 and 1.5 degrees above average. It's quite close. Red line is the ensemble mean, by the way. So that's kind of close to what CFS is showing. So the modelling is still there actually for an El Nino, and if I show you last month, back in August, the prediction, you can see that actually it has increased. So Jamstec, interestingly, has increased the forecast for an El Nino, because last month it was just kind of like on the border between ENSO neutral and an El Nino event with that red line. That's August. If I show you again September, you can see that red line is further up. So actually the Jamstec model has moved more towards an El Nino after backing off a little bit last month. I'm still very dubious about this. It's very, very late in the day, but maybe we will have certainly a weak El Nino possible in the final quarter of the year. It's going to be fascinating to see, and there is so much uncertainty with this that we won't be able to bring you our ENSO analogues until very late on in the updates this year, unfortunately. It'll be in November, I think, before we can finally bring you our ENSO analogues for this winter. Watch your space on those. Now, I said I'd feature the Atlantic, because I did forget to feature the Atlantic last week. So this is the latest sea surface temperature anomaly map for the Atlantic over here. Got a very unusual Atlantic profile. Again, we've got these cooler than average sea surface temperature anomalies to the south of Greenland. Then it gets very warm through this central part of the Atlantic, particularly over towards Newfoundland and that northeastern coast of America. And then the tropics looks like they're cooling down again. They did warm up a little bit around a month ago, but since we've had this burst of hurricane activity, actually it started to cool the sea surface temperatures down a little bit in the tropics. So we've got 3 distinct bands, but they are cool and warm and cool, which isn't a particularly good profile if you want a colder winter. But it's a very unusual profile, that the warm waters with warm sea surface temperature anomalies that are sort of gathering there to the sort of Atlantic side of North America. They're very unusual, and we're going to have to go through the sea surface temperature anomalies and see if we can find any years that match up. We go all the way back into the 1980s, and I think we'll probably do that next week. I think next week will probably be a bit of a sea surface temperature anomaly special for the Atlantic, and we'll go through all of those years and see if we can match up a little bit to this year. Maybe we won't be able to find a match. Maybe this is so unique there'll be no year that is matching. But it's worth having a look anyway. I think that's what we'll do next week. Sea surface temperature anomalies remain significantly warmer than average up there in the Norwegian Sea. By the way, that's something that we had that last year, and there is a bit of speculation that some of the blocking that we had last winter might have been down to those warmer than average sea surface temperature anomalies in the Norwegian Sea. We still have those. Talking of last year, this is how the sea surface temperature anomalies were looking at this point last year. Just to whet your appetite a little bit for what we're going to be doing next week when we go back through the years and the decades to try and find a match to this year. But this is how things were looking last year. In the terms of the sea surface temperature anomalies, you'll notice a weak landing signature in the ENSO region, very different to this year. Quite a bit cooler in the northeastern Pacific. And in the Atlantic, well, there's that warm area in the Norwegian Sea. Also, though, much warmer through the tropical Atlantic. One of the reasons we had big hurricane season last year was that we did have warmer sea surface temperature anomalies through the tropics, and also warmer to the south of Greenland as well. So we've got a very different profile in the Atlantic, sea surface temperature anomaly profile in the Atlantic this year to last year. As I say, next week we're going to go through the years and through the decades and see if we can match up to this year, to 2018's sea surface temperature anomalies. Juxtaposed to this is the 2018 Atlantic hurricane season. So this is the latest in terms of the 2018 Atlantic hurricane season from Wikipedia. We scroll down, have a look at the latest numbers. Everything is up on last week. So at the moment we are standing at 10 total depressions. We are standing at 10 total storms. That's up from 9 for both of those, so they're both up 1. We are at 5 hurricanes, which is up 2 from 3 last week. The only one that hasn't moved is major category 3 or above hurricanes. That is still just standing at 1. Hurricane Florence, of course. So other than that, all the numbers are up, but this is still a fairly modest hurricane season, to be honest. However, this is quite interesting. This was pointed out by my good friend Richard Trott a couple of days ago, and I thought I'd just include this because it is quite interesting. So we've got 3 years going on here. We've got 2010 just there. How easy can I draw a straight line? Not very well. That's 2010. And then we've got this one is 2017. Last year, 2017, and then this one on the bottom is this year, 2018. Now, the similarity that we've got here is the areas within the tropical Atlantic where we've got those 3 tropical storms or hurricanes going on. So in 2010, we have Carl just there, we have Igor just there, and then we have Julia just there. Last year, 2017, we have Katia just there, we have Irma just there, and then we have Jose just there. And then this year, 2018, we have Florence just here, we have Isaac just there, and then we have Helene over there. So it looks very similar in terms of those 3 sort of storms that are going on through the tropical Atlantic around this point in September over those 3 years, 2010, 2017, 2018. Of course, 2010 precedes the December to remember. 2017 precedes the much colder winter we had for 2017-18. And then 2018, but we can't say what those 3, Florence, Isaac and Helene, are going to proceed. But certainly a bit of a similarity between the 3 years of 2010, 2017 and also 2018 too. Food for thought, maybe. Right, so we're 33 minutes in, and I'm going to pause the video there. Let's move that over from stop to pause. I don't want to stop that and lose the recording. So we're 33 minutes in. I'm going to go and get a drink of water, go and get yourself a cup of tea. We'll meet back and we'll go through our analogues package, which this update is going to be looking at those very dry summers and the winters that followed them. So I'll see you in around 2 minutes. Okay, we're back and we're ready to resume the third Winter 2018-19 update, all hopefully refreshed and raring to go. So the first part of the update looked at sea surface temperature anomalies, what's happening in terms of Arctic sea ice and snow cover, that kind of thing. The second part of the video is going to have a look at our analogues packages, and we're going to be looking at the driest summers on record in terms of the England and Wales record. We're going to have a look at the driest summers on record and the winters that followed them. Follows on from last week where we looked at the hottest summers on record and the winters that followed them. If you want to know what winters were like that followed hottest summers on records, do please check out the second Winter 2018-19 update. So we're going to have a look at the driest summers and then we'll put both the hottest and the driest together if we can. It's going to be a little bit tricky to do that, but we will have got around 3 years that we can put together. Anyway, more of that later. We're going to begin by having a look at these driest summers. So obviously summer 2018 was a very dry summer as well as being a very hot summer. It is within the sort of top 20 driest summers on record, particularly for England and Wales. This is from the UK Met and it shows you the summer rainfall amount in terms of a percentage to average set against 81 2010. See, very dry summer for England and Wales. Not quite as dry in the southwestern parts of Scotland, Northern Ireland, but eastern and northeast of Scotland did have a very dry summer as well. So let's go through the top 22 driest summers on record. We start at number 22, which is the summer of 1911. Remember, it's for England and Wales. This is the England and Wales driest summers. So we begin with summer 1911 at number 22. This is the winter of 1911-1912, and after that very hot and dry summer in 1911, it's a very wet winter, mild winter too, with a strong westerly Atlantic driven flow. Number 21, in terms of the driest summers on record, is 1937. This is how winter of 1937-1938 looks. So quite a strong blocking signal, actually, this summer. I'm a little bit surprised about that because it's not really remembered as a particularly cold winter, but it looks like there would have been some pretty cold conditions at times through the winter of 1937-1938. Number 20, in terms of the driest summers on record, is 1940. This is how the winter of 1940-1941 looks. So it's another one of those very cold early 1940s winters. There's 3 of them, 39, 40, 40, 41, 41, 42. This one has a very strong blocking signal around Greenland with the below average heights underneath it. And we pull in those bitterly cold east or northeast wind. That's a very cold winter in 1940-1941. Number 19 for the driest summers on record for England and Wales is 1985. Maybe a little bit surprisingly because that was a very poor summer, but it's also a reasonably dry summer at times, especially I think through June and even into July. The winter of 1985-1986 looks like that, with below average heights to the south, above average heights out to the northwest, and also over to the east of us as well. The interesting thing about this winter is that cold is kind of like on and off through December and through December 1985 and January 1986. It's been on off, but then it gets extremely cold by the time you get through to February, severely cold in February 1986. Number 18 in terms of driest summers is 1947, and this have a winter of 47-48 looks. It's a very mild Atlantic-driven winter, very, very different winter compared to the one before it, 46-47. That's a severely cold winter, but 47-48 was very mild and Atlantic-driven. Then number 17 comes out as the summer of 1868. The winter of 1868-1869, which we've talked about a lot in the analogues updates over the past few weeks and months, is the mildest winter on record for the central England temperature region. It has all of this high pressure to the south, southeast, low pressure to the northwest, and a very strong flow coming up from the Azores makes it, for the central England temperature region anyway, the mildest winter on record. Number 16 comes out as 1981. The summer of 1981 was the 16th driest in England and Wales temperature precipitation series. The winter of 81-82 looks like that. So it has below average heights, generally centred to the south, has a strong blocking signal. This is an interesting winter because it contains a severely cold December. It also got very cold for a time during January, and then it has a very mild February in 81-82. Number 15 for the driest summers is 1955. The winter of 1955-1956 has below average heights to the southeast and a blocking signal up to the north. Again, very similar winter in some ways to 85-86, in that it wasn't particularly cold until February, and then February 1956 turns severely cold again. Number 14 for the driest summers is 1975. This one shows that we have the above average heights over the UK, so it's a mild but dry winter for 75-76 with the jet stream to our north. 1921 shows up as the 13th driest summer on record. This is how the winter of 1921-1922 looks. So for the UK, it's quite a mild and wet winter. I was taken to task a little bit by somebody on YouTube a week or so ago who pointed out that 1921-1922 for much of Central Europe was actually a very cold winter. So just going to show the difference you can get within a few hundred miles. But for the UK, actually this was quite a mild, wet winter in 1921-1922. Number 12, excuse me, number 12 for the driest summers is 1899. This is how the winter of 1899-1900 looks. So again, we see that we have the below average heights over the UK and to our south. We have the above average heights to the north. This is quite a cold looking signal for the winter of 1999-1900, and we're on the cold side of the jet stream as well. That's number 11, and it's 2018. Yes, the summer of 2018 was the 11th driest summer on record for England and for Wales too. What are we going to see for winter of 2018-19? It all remains to be revealed, but yeah, we'll know in a few months' time. Right, we're into the top 10. So the 10th driest summer on record is that of 1870. The winter of 1871 looks like this. It's a very strong block signal following that dry summer. A lot of northern blocking with below average heights to the south. You will think that's a very cold winter in 1870-1871. Number 9 is the summer of 1984. The winter of 1984-1985 is cold. Notice a lot of cold winters are showing up with this analogues package. Very, very interesting. We have seen a lot of the classics here. So, winter of 1984-1985 shows a strong blocking signal to the north of Scandinavia. It favours easterly winds as well. Number 8 is the summer of 1949. The winter of 1949-1950 has below average heights to the west of the UK, and we bring in this westerly flow. Quite a mild winter for 49-50. Number 7 is 1864. The winter of 1864-1865 looks like that. It's another cold winter with a blocking signal towards Greenland and below average heights to our southeast, probably putting down cold north or northeasterly winds with that one. Number 6 is the summer of 1913. The 6th driest summer on record is 1913. The winter of 1913-1914 looks like this, with again below average heights, very close to the UK. So it's an unsettled winter and quite a mild winter, this one. No blocking signal to force cold air out of the pole. So generally a mild but fairly unsettled winter, the 1913-1914. We're into the top 5. The 5th driest summer for England and Wales is 1887. The winter of 1887-1888 is cold, with below average heights to the south, and then we have this blocking signal around Greenland and Iceland, forcing cold air into that trough of below average heights. Has a severely cold Christmas to New Year, I think, in 1887. The 4th driest summer on record is 1983. The winter of 1983-1984 is unsettled. Again, we have this big area of below average heights around Greenland and Iceland. And usually with this one, we actually bring down a northwesterly flow and quite a cold Atlantic-driven winter in 83-84. Number 3, the 3rd driest summer on record is 1889. 1869, that should be. The winter of 1869-1870 looks like that. Below average heights centred over the top of the UK. It does have quite a strong blocking signal around Greenland and Iceland, so I assume there would have been some cold weather. The main thing is it looks a very wet winter in that one. The 2nd driest summer on record is 1976. Maybe a bit surprising. A lot of people think 1976 would be the driest summer on record. It's certainly the hottest summer on record, but it isn't the driest. It's at number 2 for the driest summers on record. The winter of 76-77 looks like that, with the above average heights to the north of the country, below average heights over the UK. So it has a cold December, there's cold on and off through January, and then a very mild February. And then the driest winter on record for England and Wales. Let's flip that over because that 9 shouldn't be, that should be a 1. The driest summer on record for England and Wales is 1995. Yes, 1995 was a little bit drier than 1976, but not quite as hot. So for the winter of 95-96, we know it's a cold winter, one of a few cold winters that we have in the 1990s, with the high pressure around Scandinavia. Very easterly winter as well. We have a lot of easterly winds. It's on-off cold, a really cold spell around Christmas of 1995, and the rest of it sort of on-off. But the main thing is very easterly winter for 95-96. Putting all of this together then, all of those years combined, we see this signature for December. So very interesting. We do have a blocking signal around Greenland and the North Atlantic for December, with the below average heights across Central Europe. The Decembers, therefore, can be cold in these winters, maybe favoured to be cold in these winters that follow these very dry summers. The Januaries also have really quite a strong blocking signal as well. Above average heights to the north of the country, below average heights generally centred over to the south of the country. And so again, it does differ of course from year to year. Not every year will be identical, far from it. But over the package, it does look as though the Januaries also can be favoured to be cold, and this continues into the Februaries as well. I'm sure this is a real surprise for most people. It certainly was for me to see this come together. The Februaries for these very dry summers tend to favour the high pressure over Scandinavia and going over to Greenland and Iceland. The below average heights down here perhaps not quite lined up as quite as well in the Februaries, but even so, it's a strong Scandinavian high signal that we have there for the Februaries. And so more often than not, because remember this is taking all of those years and combining them, so with such a strong Scandinavian high signature, I think more often than not you would expect cold conditions in the Februaries. The Marches also look very interesting. Look at that blocking signal again for the Marches around Greenland and Iceland. So an extended sort of cold winter is possible here when we have these dry summers and then the winters that follow them. Definitely a cold signature in the Marches too. Combining all of the months and coming up for a winter combined chart, well, it's a blocking signal. Look at that around Greenland and over towards North Scandinavia. We have above average heights, below average heights over into the south of the UK, and bringing in those east or northeasterly winds. If we just narrow this down to the top 10 in terms of the driest summers, this is how we look for the top 10 dry summers and the Decembers that follow them. It's a very similar signature. We have the blocking signature to the north of the UK for the Decembers, with the below average heights to the south. So again, December favouring colder conditions. The Januaries look even more spectacular. Look at that for the Januaries in the top 10. With these dry summers, with the blocking signal to the north, the below average heights to the south, and again we pull in those east or potentially northeasterly winds in the Januaries. But Februaries also look pretty conducive to cold conditions too. Remember, there will be years that deviate, so it's not guaranteed. Nothing is ever guaranteed with the weather, but this is a strong blocking signal that we're seeing here for these winter months through the top 10. The Marches, I mean, look at that for the Marches, with that strong blocking signal that we have there around Greenland and Iceland. It not only does it look like we could have a cold winter from these summers that follow, from these winters that follow dry summers, it looks like it's extended as well, because there's a strong blocking signal for the Marches. In fact, the Marches maybe have the strongest blocking signal of all. So very, very interesting data that we've got going here in terms, again, of all the months combined for the winter. This is all winters combined for the top 10 driest summers. Again, we have this big blocking signal up to the north, but below average heights to the south, and those east northeasterly winds are coming in. The connection could be through high pressure. Maybe when you have a very dry summer, it tells you you're having a very blocked, so having a lot of blocking. Maybe that's the connection. Who knows? So just going back to last week's update, we looked at the hottest summers on record. Let's deal with the top 10 hottest summers on record. Start with 76, 1826, 1995, 2003, 2018, 2006, 1846, 1983. 947 and 1933. They are our top 10 hottest summers on record, and they're the CETs for those summers, of course. These are the CETs for the winters that follow them. I haven't got time, I'm afraid, to talk you through all of those winter CETs. You see 2018 showing up as the fifth hottest summer just there, and the question marks because we don't yet know what the winter CETs will be 2018, 2019. So as for top 10 hottest, what about the driest summers? So these are the list of the driest summers on record. Again, top 10. We're looking to see if we can match years between the hottest and the driest. So for the top 10 driest, we've got 1995, 1976, 1800. Some of these years we haven't been able to show you, of course. 1869, 1818, and so on and on down the list we go. We're looking to see if we can match up. And what we've come out with is 1976, 1983, and 1995. Those 3 years show up in both the hottest and the driest summers. So, in the final analysis, if we put the hottest summers and the driest summers together within our top 10 tables, we find that the Decembers of 1976, 1983, 1995 look like that, with a blocking signal to the north, below average heights to the south, and we bring in those east or northeasterly winds. But January is following those 3 hot summers and dry summers. Top 10 driest, top 10 hottest look like that. So the signature for the January, again, it's a blocking signal. The blocking is more over to the east and northeast, so below average heights down to the south. Possibly brings a little bit more of an Atlantic influence, but again, blocking is very dominant. February's look like that. So again, we have below average heights centered over to the south of the country. Above average heights are centered up to the north. And then the Marches, again, very strong signal for a cold March with below average heights down to the south. We have the above average heights of blocking to the north, with favouring easterly winds in the Marches. But all of the months, you'll notice, all of them, December has a strong blocking signal around Greenland and Iceland. January has it more over towards Scandinavia and the Arctic Circle. February, again, favours it more towards the northeast of us, perhaps. And then March really brings it towards Greenland and Iceland. If we put it all together, those 3 winters, 76, 77, 83, 84, and 95, 96, that's how we look, with the above average heights to the north, but below average heights to the south. So this could well be a cold winter signal from the hottest, top 10 hottest and top 10 driest summers. Finally, December to March looks like that. Again, it's a cold signal with blocking to the north, below average heights to the south. There's those easterly winds coming in from the east and from the north. Really surprised at those analogues, particularly the driest summers are favouring the chance of a colder winter, or a cold winter, really, with blocking signals in all of the winter months. I'm very surprised at how that's come out, but we can only show you what the analogues show, and that is indeed what the analogues show. Finally, if you're enjoying the winter updates, please can you consider becoming a patron for GWV and giving us an ongoing monthly donation. It's helping us to pay for our website. So this is GWV's Patreon page. You can come here and you can become a patron for GWV. Alternatively, if you would prefer to give a one-off donation, you can do so through the GWV.me PayPal page. That is it. So you've got a PayPal account, very simple. You just come to this page, sign into your PayPal account, and you can give us a one-off donation. You are helping us to pay for our website. You'll get a shout out in the videos at the same time if you want one. Some people chosen not to have a shout out, but if you want one, you'll get one. And it's helping us to pay for our website. It helps to keep all of the content completely free of charge. So a big thank you to everybody for doing that. And I think that's pretty much it for the third Winter 2018-19 update. Later on today, this video will be placed on the Winter Updates and Forecast page by the extensive written summary that goes with it as well. So at 56 minutes, all that remains is for me to say thank you so much for watching. Come back next week. We're going to be an Atlantic sea surface temperature anomaly special next week, amongst all of the other things. There'll be some analogues too. So come back for the fourth Winter 2018-19 update next week. But that's all for now, and thanks so much for watching.